Good afternoon. My name is Maggie. It's good to have you here. Welcome to the R&D sessions powered by EDP. We are the Research and Development Center of EDP Group, and we work mainly with European projects, looking at innovative solutions for decarbonization, smartification, and flexibility of the energy sector. The aim of these sessions is to get together experts to discuss several topics regarding the future of energy, the challenges that we are facing, and the solutions that we are already putting into practice. Please note that these webinars are recorded and the previous sessions are available on the EDP's website. You can just scan the QR code on the slide that is being presented. Also, this session will be available in our website and YouTube channel in a couple of days. For today's webinar, we have 3 guest speakers that will share with us their insights. So I want you to use the Q&A chat to ask your questions to them, and they will answer at the end of the session. With no further delays, we welcome you to this event, and I wish you all a great session. But first, I will introduce our moderator, Motash. Motash, thank you so much for accepting the invitation to be here with us today, moderating the R&D session. Motash holds a PhD in electrical and computer engineering from the University of Porto and a master in future power networks from Imperial College in London. He has built a solid foundation in electrical power systems with a primary focus on state estimation in hybrid HVAC/DC systems. In 2023, Motash joined EDP Group, the R&D Center, and now is an R&D engineer working on projects related to grids, networks, resiliency, and power system studies and simulations. Before that, he worked at FASEC, initially as a system R&D engineer and later as a protection and control R&D engineer. Thank you so much, Motash. The floor is yours.
Thank you very much, Maggie, for the full introduction. As always, I welcome you all for this session that we have mainly 3 speakers today on the agenda. So basically we will have 3 sessions, starting on the first one that is basically about the experience with drones and AI services for electrical asset maintenance in the RTD projects, which will be presented by Ugo Sticky. Then it will be followed by another session, AI and robotics in overhead power line inspection, EDP Lablik use case by Hendrik Will. And finally, we'll have another session, automated substation inspection with drones and AI, or plus, at the event you would like to say, AI platforms by Reto Gomes. And lastly, we will have our Q&A session. So without any further delay, I would like to introduce the first speaker of today, Ugo Sticky, who holds a PhD from 2011 in power system. He started his career in 2005 as a designer and consultant in electrical systems. From 2017, his main involvement in R&D established and technology transfer projects in different energy companies in Spain. And from 2021, he joined the new technology department at ETRA as a project manager coordinating several horizon projects in the energy system area, as we're going to see one of these projects today now. So Ugo, please, the floor is yours. Feel free to share your presentation, and I will stop sharing mine at this point.
Thank you, Motaz. I hope you can hear me well.
Yes, we can.
Thank you for invitation. Thank you for hosting this interesting event. And good afternoon to all the audience. My name is Ugo Stecchi, and I work at ETRA as R&D project manager. And my presentation is entitled Experience with Drones and AI Services for Electrical Asset Maintenance in R2D2 project. So I'm taking time of my presentation, Motaz, in order not to be late, but this is the agenda of my presentation for the next 10-15 minutes. I will give you a brief introduction of the company I work and I belong to, ETRA. Then, of course, I will give you some main information main outlines of our R2D2 project, the project that I'm coordinating, and we are participating in this project along with EDP New. And within this project, we have selected three different use cases as an examples of activities that we have performed within this project with drones and the AI tool for the automatic detection of anomalies and failures in electrical assets, especially the first one in overhead lines inspection. The second one about PV plant survey with drones, and the third one for substation power transformer inspection. So, as I told you, I work at Tetra, and especially in Tetra I&D, which is the R&D company within Grupo Etra. Grupo Etra is a Spanish company based in Valencia with almost 2,000 employees all around the world, mainly in Europe and Latin America. And we are working in several sectors. We started back in the 70s from mobility and traffic, and we expand our business in energy, security and control, water management, and communication also. So we have a strong presence also in a European funded project, research and innovation project, as Motaz has introduced before, and R2D2 also is one of these projects. We are mainly involved in different Horizon Europe projects in several sectors, especially energy is one of these sectors, of course. We have a strong presence in three different areas of this kind of project: mobility, security and ICT, and of course energy. We run approximately 60 European projects and coordinated around 20 of them. And of course, the portfolio of our project is always updating. And for this presence, in Europe, we have been recognized with one of the top 1% most innovative companies in terms of granted project, and also one of the main companies in Spain. But now, let's give some information about our R2D2 project. Its full name is Reliability, Resilience and Defense Technology for the Grid. It is an innovation action with a total budget around 10 million euros. And it started back in October 2022, and it is about to be completed because its deadline is the end of this month. So Motaz, hopefully in few days, we will succeed to complete all the activities in this project. The three main objectives of this project are demonstrating the increased solution for energy system reliability and resilience, preventing disturbances and ensuring the rapid recovery after a resilience event, and demonstrating and validating the effectiveness of the solution developed in the project in relevant environment and real-life environment. In R2D2 project, basically, we developed four main products. The first one is called C3PO, which is a big platform for risk assessment. The second one is called IRIS, which is a tool suite for coordination of TSOs and DSOs during extreme event related with security of the systems. The third one is called Precog, which is the tool suite within R2D2 mainly focused with the cybersecurity aspects. It includes several tools for TSO, DSOs, and the regional security centers for cybersecurity, for prevention and risk assessment also. And the fourth one, it's called EMA, that is basically a big platform, including planned outage management and unplanned outage management. And within the unplanned outage management, there is a tool suite called Argos. That is the tool that we are going to present some results today. And this tool basically includes several AI models to analyze different images, videos, thermal images also, and others kind of sources from the fields in order to detect and provide alert of possible failures at electrical infrastructures. The full adoption of these four modules will allow the users to as you can see on the left side of the screen, to cover several ranges of outages from high frequency, low impact outages up to high impact, low frequency events, the ones that are most extreme events. The R2D2 project have four different pilot sites, Hedno, the DSO in Greece, the TSO and Regional Security Center in Serbia, the DSO of Slovenia, and of course the EDP New with Iredesh and EDP Labelec that is hosting this session this afternoon in Portugal. What we want to do with Argos, of course, is try to migrate from the typical corrective and preventive maintenance strategies to the predictive maintenance strategies, including several functionalities of communication and connectivity, leveraging, of course, the main functionalities from drones, and of course, everything based on the possibility to extract information from AI tools. Everything to reduce cost, improve continuity of services, minimize downtime and failures, and speed up the recovery of the system in case of failures. All these aspects will provide to increase the indicators for reliability and resilience of a distribution system. The first use case that I'm going to present is one dedicated to the overhead line inspection. It was made with infrastructure made available by EDP Group, and they provide information of the medium voltage overhead lines in Óbidos region in Portugal, with the aim to reduce vulnerability from natural and environmental factors, extend the range of the manual inspection, and try to have a more promptly reaction when in front of an incipient failure that may arise. This is a screenshot of the Argos tool that you can see now. Basically, Argos is able to analyze LiDAR images, RGB images, and thermal images. LiDAR, of course, is for detection of obstacle and vegetation. Thermal for hotspots, and you can see here below in my screen, and the RGB for possible mechanical damages or missing parts in the towers or in the poles. The structure of the user interface is basically very similar to the one of the LiDAR, so it is possible to identify the assets, and according to the portion of the lines that we are visualizing, there is basically a windows with several alerts. In this case, are alerts about the vegetation. The LiDAR analysis is shown here. The second use case is that I'm presenting is one related to the PV plant inspection. We run some analysis in a PV plant in Spain. You can see here the location of the Spain. We selected a portion of around 2.5 megawatt power of a 16 years old plant. The owner of the plant, of course, want to speed up inspection, reduce the cost of the maintenance, but also have a more clear indication of the anomalies and potential faults of such old plant. In this case, Argos has a different windows for analyzing this kind of images. Analysis can be done on RGB and infrared images acquired via drones, of course. The analyses are compliant with these IEC standards that you can see here. We have 4 set of categories of anomalies and 16 different subset of categories. So the user can select or can identify exactly which is the anomalies. If it is an anomaly, it is maybe a shadow or something like this. Alerts are editable, so the AI model can be retrained in real time, and this way the asset owner is able to extend the profitability of the PV park itself. The final use case that I'm presenting is again a use case that we performed with the colleagues from EDP. In this case, they provide a substation in Alheim region in Portugal, 30 kilovolt substation, with the aim of course, improve what are the current inspection that are mostly manual. Personnel have to move to remote sites. There is sometimes a lack of real-time information, real-time signals from sensors. And so we have, in this case, EDP has flown some drones in the area to acquire RGB and infrared images over power transformers. Here you can see an images of one of the power transformer that has been inspected of 30 MVA. In this case, there is another interface within Argos that is able to acquire images from the drones. We consider that flying a drone in a substation is maybe one of its kind experiment. And Argos, in this case, is able to identify the different section, the different components within the transformer, setting different temperature threshold of the transformer, and triggering an alarm in case of over temperature in each one of the different section. Also, it is possible within Argos to include measurement from SCADA, in order to perform cross-check analysis and matching temperature analysis from ER images acquired via drones with real-time information acquired from SCADA. So to sum up, these are the main features that we have thought that Argos that should comply with. It is basically a software as a service platform. It has been conceived as hardware and vendor agnostic, so it is basically to acquire information to whatever kind of drone until this information. For information, I mean videos and the images, and also the payload from which these images are acquired are in line with some requirements. It has some interoperability also of data in order to acquire information from SCADA, reducing also the timing for the operation from the visual and manual operation. And it has been also conceived in order to have some, this kind of friendly usage from those users that are not so keen to data analysis and AI models adoption. And of course, these are the results of a research project. Even though we are happy with the results, there are still some work to do in the next month after the project. We are keen to find more actors to complete the validation in further real life scenarios in order to enrich also the models through the acquisition of many more data sets and improve the training of the AI model. And then there is also the preparedness for BV loss missions. That is something for the future. So if you want to know more about this project and our tools, you can visit our website, ETRA, and also visit the R2D2 project, where there are lots of information about the tools that we have developed and much more tools. And here you can see all the links that we have provided, where many more information and data are available. So that's it from my side. Thank you for your attention. And Motas.
Thank you very much, Ugo, for the good presentation. And indeed, as the project is ending, it was quite a journey. And as you said, still a lot to come afterward for scaling up and replicating the tools that has been already developed. So I believe if everyone got this slide, I will share now back on my side. Next, to complete, so we are now moving to our second speaker. And if you allow me quickly, yeah. So our second speaker is Andrea Quill from EDPublic, the head of the asset inspection at EDP Public. With the extensive experience in electrical networks, Andrea is specialized in radar and infrared data collection using both helicopters and also UAV platforms, mainly from power system assets. And Andrea is also specialized in data analysis with a strong focus on AI-based image recognition applications. Andre, the floor is yours. Feel free to share your presentation. And let's see. Thanks.
Okay. Thank you, Motas, for this kind presentation, and thank you for the invitation to present this EDP Lab use case. Well, as Motas said, my name is André Coelho. I work at EDP Lab, and this presentation will be about how AI and robotics are impacting overhead power line inspection at EDP Lab. Well, starting by a small introduction of EDP Lab, we are a company from the EDP group. We are in the networks platform, and we specialize in engineering and technical consulting services, which means that we help our clients managing their assets. One topic where we help them to do this is on power lines by performing power line inspection. So for us, power line inspection is a process where we basically try to understand the technical condition of the assets. We used to divide these in two phases. One is the data collection, and the other one is the data analysis. The data collection is basically collecting raw data from the assets, and we can do it through several means, more by helicopter or by drones. And then the data analysis is where we build valued information. That is, in practice, the identification of things that are not correct and the corresponding severity level. To do this, we typically use three types of data: RGB to detect structural defects on the assets, infrared to detect overheatings, and LiDAR for detecting proximity between vegetation and constructions and electrical conductors. Looking at this activity from an historic perspective, it all started by foot patrols, and then the activity became more specialized, first with the use of helicopters and then with the use of drones, and also by adding, I would say, more advanced sensors like LiDAR. Today, we have an operation that is with about 75% of our annual volume of inspections done with the use of drones. And I would say that in the last 5-10 years, we realized that automation, robotics, and AI started to play a very important role in this historic evolution. These are the main reasons why we started to use AI and robotics in power line inspection at EDP Lab. First, because we felt that these technologies are good for anticipating business future needs. We also realized that we also we started to use AI and robotics because of accuracy, because typically power line inspection has several repetitive tasks, and normally this technology can help us to increase consistency and reduce fatigue across this process. And because of efficiency, because taking into account the collected data related with these tasks, tools like these, or without tools like these, it would be impossible to achieve the execution and the service level agreements that we are delivering. So in the next slides, I will try to illustrate with 2 examples this adoption. One is related with how we are using robotics for data capture, and the other is related with how we are using AI for defect identification. Well, as you remember from the slides of our historical evolution, in the recent years, we have been challenged to increase drone data capture in this activity. And there are several reasons why we are growing drone data capture, but we can choose 3 as the main reasons. Safety, because we want to minimize the impact of potential accidents. Sustainability, because, well, it is easy to understand that drones have a much lower carbon footprints. And of course, because of efficiency and in a way of paving the way for a potential cost reduction. So with this growth, some challenge appeared, and that's why we start to look at these technologies. On one hand, increasing drone data capture requires more field teams to perform this activity, and it's simple because one team using drone capture much less than one doing the same with an helicopter. So teams performing drone data capture increase, and on the other hand, the back office effort also increase, because since it is necessary to increase field teams, their expertise must focus on drone operation rather than the ability of inspecting power lines. So typically, the defect specialist, people that are well trained to detect defects on power lines, concentrate their activity at the back office and analyze the network based on images that are collected or captured by the pilots. And those pictures needs to be, or the number of those pictures needs to be in quantity to characterize the entire asset, which of course increases the number of tasks that are done at the back office. So to overcome this challenge, we try to apply robotics and AI to our process. So first on the data capture, if we have kept this manual capturing with drones, well, with pilots doing their capture only with the ability of their hands, with the growth of field teams performing these tasks, the data capture would have some challenges. One is the data variability, because each pilot tends to capture data in a different way. The productivity, because we have faster pilots and also slower pilots. The training would be also much more complex, because with more pilots, more different people doing this, training would be more complex. And of course, the risk of incidents, and by incidents I mean crashes, would also increase. So our main choice was, since the beginning, was to reduce the manual data capture and to adopt automation on the routes of inspection of each drones. Basically, what we wanted to do is to reduce the degree of freedom for each pilot, giving them tools to perform better, but with lower risk. For that, we have developed an application that basically starts with off-the-shelf software development kits that most drones have, and use inventory information and pass collector LiDAR to automate the flights. That's the path that we took. To help on the back office activities, our solution was a little bit different. It was basically trying to use AI for defect identification on pictures. And in this case, the idea is to have an application that uses the RGB pictures that are collected on the collection process, and then that process them to help our specialists to increase their efficiency. Well, of course, while keeping the quality of the information in an high standard. So the balance of this between this automation and quality is the key of the process. For addressing this balance problem, our strategy relies in two different vectors. One is the combination of AI and human expertise, basically where AI gives suggestions, says that probably in that picture there is a problem, and then every defect needs to be validated by a specialist. The sector vector that we used was also to use our final information that we must produce anyway, not only to deliver to our client, but also to promote regular training on the model. So that's the two vectors of the strategy that we use for our AI platform. So, like looking back at the growth of this drone activity, and at the fact that we are delivering results under very, very demanding SLAs, it becomes clear that this technology, AI and robotics, are having an impact on overhead power line inspection in our overhead power line inspection activity. And this is also positive because it allows people to focus their energy and expertise on tasks of greater complexity and greater value. And this is good because it develops the activity. And one example of that is being able to extract more value from the data, from the same data that is already collected. So a very good and very positive impact of AI and robotics on our use case. To finish, and in my last slide, I would like to share three key messages. One is that power line inspection is key for grid asset management. Okay, drones are becoming very important for performing this task. And last but not least, tools like automation and artificial intelligence, robotics, are topics of high value for improving accuracy and efficiency in this process. Thank you.
Thank you very much, Andre. Very interesting and insightful presentation, and also the numbers are quite interesting to see how scaling up things are going. Also, I would like to remind all the audience that you can put your questions, but at the end we will have our session. So please don't keep it until the last, but as we go, you can put your questions. So moving to this third speaker for today, we have Renato Gomes from Pixforce. He's the founder and the president of Pixforce, and over the past 9 years, he has led the company from a deep tech concept to a trusted global player in applied AI. Under his leadership, Pixforce has expanded operation from not only Brazil, but into international markets, with the clients on almost all continents. So Renato, the floor is yours. Feel free to share your presentation, and let's kick off.
Lovely. Thank you, Montage, and thank you to both previous speakers. I think we're nicely moving here around the theme of artificial intelligence and automation, or the present of the inspection. So I'm happy to wrap this up and I think shed some further light on how we are swiftly progressing to a much safer and much more precise form of automated inspection. So at the outset, I want to talk just briefly about Pixforce, because even though probably the youngest one here in terms of companies, we are already 9 years old. So we've been in the market since 2016. really developing software for computer vision. So our focus has been really around the software components. But as you'll see, and as I think prior speakers have mentioned, many times for us to be able to deploy computer vision optimally, we have to acquire the images in the best possible manner. It's doing this type of solution, not only for the inspection of electric utility assets, but assets more generally, that PixForce has gained clients across the globe, normally in heavy and large companies, right? A lot of oil and gas, a lot in the mining and steelmaking sector, but first and foremost in the electric utility sectors with companies like CEMIG in Brazil, companies like CLP in Hong Kong, and of course, EDP there in Portugal. We have a global presence. I am personally based out of Helsinki, where we are leading the efforts here in Europe, but we do have offices in Houston and Hong Kong. Most of our team is still based in Brazil, where we do most of our development and a lot of the benchmarking work that we do with early stage clients. We do have a large team. Well, I have to give a shout out to the leadership, but the fact is that this is only a select few among over 100 employees at PixForce, and the level and the passion of what we call our PixWiz, the wizards behind PixForce, is really what makes what we're doing possible. So the leadership is only a reflection of the great team we have working around the globe for us. So what are we doing? What's computer vision, right? So let me take just a quick step back, because I think this is essential, and it's something that in any sector, when you have a process where you have a human doing any analysis using visual components, it is now a moment where we're going to see a lot of change. Why? Because of three major shifts that have happened over the years. The first one, which is somewhat obvious, as soon as you look at your mobile phone, you see the quality of cameras, right? You see the camera on your cell phone today is significantly better and cheaper than any digital camera you can have bought 15 years ago. And more than that, as was mentioned by previous speakers, the cameras are now flying, right? We have the drones which are automating the acquisition of the images. So there has been a world-changing shift in the way that digital imaging is done. The second component are the graphic processing units, right? So these are the specialized chips which are used for the processing of images, of videos. And the fascinating thing around GPUs is that they start a lot around the gaming industry, but because they've become faster, they've become much more flexible in the way you can program them and much more resilient. They're much more able to withstand false programming lines and withstand the needs of deploying it in the field, have really allowed us to take computer vision from out of the labs and into the real world. The last component, and the obvious one, is artificial intelligence, right? I mean, 20 years ago, this was still somewhat of curiosity from an academic perspective, but over the last 5 to 10 years, the accuracy, the capacity to edit and develop it, and of course, the safety that there is around the solutions and minimizing the false positives have allowed the deployment of AI to industrial level requirements, as we see in the electric utility sector. So in a nutshell, this is a vital slide, irrespective of what any company does, because it really is not the change in one technology, not two technologies, but three major technological shifts that allow us to do what we're doing. And what is that PixForce is doing in the electric utility sector? It's a solution that we call PixFlight, which is really leveraging the automation of the acquisition of the images, organizing these images automatically. After all, the fact that images have become cheaper to collect means that many times we have too many images and we want them neatly collected so that not only an AI can look at it in a structured way, but also humans can double test and verify the results from the AI. All of that bringing greater safety for whatever inspection is being done, right? I mean, especially when we're talking about electric utilities, we know how this becomes something really significant because you inspect substations, you inspect power lines when they are operating. So the risk to human life is always present. And even though the safety records in electric utility is an example for every single major heavy industry, to automate this, especially in extreme conditions, is definitely one of the objectives behind of what PixForce is doing. So PixFlight, let's talk about a few features of PixFlight, which I think illustrate quite neatly this combination of computer vision and deployments. The first one, and perhaps the most obvious one, is how precise the software that we have, and it's a proprietary software that we deploy on off-the-shelf drones. So we don't manufacture the drones, but we do deploy our software for flight on these platforms, allowing us to have a very precise flight, even in the most complex scenarios like a substation. And this can be done fully automatically, right? So in several clients, we're already deploying docks where the drone's going to be taking off and landing, recharging and streaming the video, streaming the images. So really bringing an extra degree of automaticity and efficiency so that inspections can be done routinely without even the need to deploy a team out to a substation, out to a generation facility. The second feature, which is a real natural segue, is that while the drone is flying very precisely, the positioning, angling, and zoom of the camera is also neatly reflecting this accuracy. So as you can see here in the corner of this picture, what you see here are the inspection points where the drone is flying and each one of the equipments that it's taking pictures of. And these pictures are what is going to allow an inspection which is significantly superior to what humans are doing. So the third feature is the combination of multiple pictures in one single super resolution image from angles that a human wouldn't be able to do when inspecting, be it a substation, a power line, a generation unit. And this is something that for the AI will allow for better interpretation, but it's organized in a way that even a human can come back. And when we look at this map here of a substation, the human can zoom in into one specific asset, one specific piece of equipment, verify that the AI's interpretation of that image has been done correctly. And there will be already highlights for potential issues which are arising. So what are these potential issues, right? And that's the fifth feature here that I'd like to highlight. And this is really around the different quality of the assets which are being inspected, both in the thermal imaging spectrum, so both the infrared and the RGB spectrum. As you can see here, everything is georeferenced, it's properly dated on the platform, and you even have the angle from which the picture is taken. So that's after the AI does a preliminary assessment, be it for corrosion, be it for a hotspot, the humans can follow through by verifying exactly where they need to eventually deploy on the field. This is something which allows for very safe comparison, even between assets of temperature and other issues such as a leak or oil leaks and eventual foreign objects, in this case, an early nest, but it could be a plastic bag that flew in. It can be other sorts of issues that arise and that a human has to diagnosticate. Finally, the last feature is no electric utility is made of only a single asset. So one of the beauties about the platform is that we allow the supervision of multiple assets in one single platform. So the different substations, power lines, and generation units can be visualized on a single application online, wherein following up on a discussion or the planning of inspection can be done with much greater ease. So what's the consequence for the clients, right? In sum, it's really that we have this asset mapping system which optimizes plans with the automated flight, that first step, making sure that the images are automatically uploaded and then synchronized with the platform, whereafter comes the analysis, where it's going to be driven by the AI organizing the images so you can compare the same asset from the same angle over time, making sure that the preliminary interpretation is done by an AI, and thereafter a human can check those images and compile a report based on that. So you can have a periodic report, which is going to be done for each one of the assets. And over time, the more data you have for that asset, the better you can predict when maintenance will have to be given, when you do have to intervene with humans. In our experience so far, we're seeing over 90% reduction in the time it takes for the inspection of complex assets, such as substations. And this is not to mention the safety when it comes to the monetary value that the companies can derive from saving this amount of time, but also the safety that this brings for the personnel that in many times in situations of hazardous weather, hazardous conditions, have to mobilize to do the inspection on these assets. So we really see this PixFlight solution as a way to empower the companies and make the most of their employees while they are safely in the office verifying the preliminary and the diagnostics which has been run by an artificial intelligence solution. So that's PixFlight. That's one of the main products here at PixForce. And we look forward to questions and any queries you might have on this project. Thank you so much.
Thank you very much, Lena. Very interesting and creative solution presented here. So without any further delays, we would like first to thank all the speakers, and we can now go to the Q&A session. So I will be sharing back. So we can now have all the questions that we received for these three speakers, and starting with the first question that was received from Leila. Well, it was mainly to Ugo first, but I think it can be also answered by three speakers. It's basically about the types of the images that can be provided by the drones. So we can start with Ugo, but also if you can to complement Andre and Renato, that would be also nice.
Yeah, Motaz and Leila. Yeah, for sure. We're talking about RGB images that have been also shown by other presenters. Infrared images from thermal camera, also keep it in the drone, and LiDARs. So at least for what is concerning R2D2, image analysis from drones, we also refers to these three kinds of images, if we can consider LiDAR an image.
Thank you. Any compliment from Andre?
Yes, I would say that what Ugo said is, well, it's typically the package that you use for power line inspection, for regular power line inspection, but there is some other, at least two types of sensors that could add some information that are not so usual, but sometimes they are used, which are the UV for detecting corona effect, especially on very high voltage power lines, and also some multi-spectrum images that are used for, or can be used for detecting if the vegetation is dying or if the vegetation is growing faster, these types of sensors can add some information for power line inspection and for other uses.
Perfect. And I think that's a very sufficient answer. We have another question too that was also received from the beginning. It's mainly focusing on the PV inspection, the use case of the PV inspection. And the question is the algorithm capable of detecting the level of dust accumulation? If so, could the index be used to autonomously trigger a cleaning operation? That's an example, I believe.
Yes, Motaz. The algorithm is not able to detect the level of dust, but it is able to detect if there is enough dust compared to the normal situation. And also it is able to differentiate between what it is dust, so the simple, small grains of dust that usually are in the atmosphere and used to deposit on a surface along the time, or what is it is a stain, a dirt stain, or even what it is. Since these are in the open environment, also what it is an excrement from bird. So differentiating what can be considered as cell anomalies, what actually is some dirts from these three categories. So the user of Argos in this case can understand whether it is a matter of maintenance or cleaning the PV surface.
Thank you very much, Ugo, and I think also the answer is sufficient. That's the question that you received during your session. So if any still of the audience would like to ask more questions to Etra, please raise them now. We have received one question during last session, and it's to Andrea. So it's about the last final slide, and I believe this was a very interesting figures presented there. So the question is, based on these impressive figures, what is your average processing time for analyzing, for example, 10,000 images?
Well, we tend to look at this not as a box where we put images and then we have the results. We tend to look at this as a process where a very specialized operator identifies the facts, and if he uses these kind of tools, he can increase its productivity for performing this task. So normally, what we in our process and in our way of inspecting power lines, a single specialist can cover about this 10,000 images per day, which corresponds to more or less 80 kilometers of power line. But again, it's not a box. It's not a black box or a magic box. It's a process, and that's the key of the inspection.
Yeah, I believe the question is also interesting because it can be questioned on how fast we can be in predictive maintenance, because if still the processing time is still not very high or not very short, depends on how you see it. Maybe the predictive cannot be that real time as well, but I'm guessing so.
Yeah, it's mainly to find the balance between all these variables: the speed of the processing, the help, that the accuracy, and the amount of images that an operator can inspect during a day. Very sharp balance.
Perfect. Thank you, Andrea. And we also received one last question. Actually, two questions, but they are for Pixforce, as I see. So the first one is, how do you train your AI algorithms from Eden? Yeah, just confirm. How do you train your AI algorithm for inspection purpose, such as how do you train to spot foreign object? You would need a large data set and would cover various possibilities of foreign objects. How do you tackle that? How do you tackle this issue, I would say?
Yeah, so this is a fascinating question that Mustafa raises here, because it goes towards the complexity of developing a proprietary AI model, which is what we do at Pixforce. So we're not taking an existing model and packaging it. We're developing ours from scratch. And Mustafa already anticipated part of the answer. For us to be able to diagnosticate an issue, we're talking about not thousands of images, it's hundreds of thousands of images. So to develop our algorithm to detect bird nests, we used a data set of over 300,000 bird nest pictures on electric utility equipment. Now, then you're probably thinking, so it's impossible for you to develop something comprehensive because we're talking about millions of images. But then what we do is, instead of having a specific diagnostics about what is this foreign object, you take the reverse step. You say, what is a clean electric equipment, right? What's a substation in a pristine, in a good condition without any foreign object? And thereafter, any variation on top of that generates a positive alert. So I think this is a great example here where for some things you want the diagnostics because, for example, bird nest is going to be something which is going to generate potential complications very quickly. But for other things, such as a plastic bag, you don't need to say, oh, it's a plastic bag. It can, or a branch that has flown over and fallen into the area, the safe area of a substation. You want to say there's a foreign object, human, check it out. And then the human operator determines the level of gravity and how quickly they need to intervene. Now, to conclude, it doesn't mean that we are not looking for diagnostics in the future, but we're gradually compiling these data so that later on we can have an AI that will say, look, this doesn't really matter because this is just a piece of debris that has flown in, or look, this is actually problematic because it's a metallic debris that has flown in that might generate a potential issue in the future. Don't know if we lost Motaz here.
I think we did because his image is frozen.
Yeah, well, he's very focused right now.
Well, but we were all almost finishing the session. We just had 4 more minutes. And so I suggest that we can close the event. I just wanted to thank everyone for being here present today, and especially our guest speakers for accepting the invitation to be here and to share with us all their work, and especially to Motaj because he did a really great job moderating the session. And this is sometimes not easy to conciliate organizing these events with our own work. So I just want to thank everybody for being here today, and well, wishing you a really good day. And I hope to see you all in the next R&D session. Thank you.
Thanks so much.
Thank you. Thank you.
Thank you very much.
Thank you, everybody.